Welcome to this tutorial, and in this tutorial we are going to look at Maths 2100 Analytical Geometry and Calculus Assignment 2, specific question 4, and here is the question. And the first one says, it says find the following integrals, and the first one is we are integrating, that is sine raised to the power 5 theta d theta. So how do we do this? All right, so whenever you have something, you have a trig function that is raised to an odd power, what you want to do is to separate that odd power into an even power, and of course, just an odd part of it, which is just going to be raised to the power 1. So now we separate it. It should be written as sine to the power 4 theta, and of course the other one being sine what? Sine theta d theta. So now I have this and here. And now you want to get rid of what? You want to easily replace this using something that we are calling the U substitution. So you want to go the U substitution method way here. But how do we introduce that U substitution here? So it's very easy. What you can do is first write this part, the even part, in terms of what? In terms of cos. So remember that sine squared theta plus cos squared theta is just equal to 1. And this here will mean that if I make sine the subject here, I have sine squared theta is just going to be equal to 1 minus cos squared theta. So this is what I get. But then this here is being raised again to the power what? To the power 4. So it's raised to the power 4. So if you see, if I write this as sine, so I can write this as sine squared theta, then of course raised to the power what? To the power 2. So this gives me that to the power 4. Then I have the sine theta here, d theta. Okay, in that way, I can now replace where there's sine squared with 1 minus cos squared theta. Then I'll have 1 minus cos squared theta squared. Then I have the sine theta d theta. So now, how you introduce your U substitution here is you want to let your U to be equal to cos. So if I say U should be equal to cos theta, if I get U equal to cos theta, when I differentiate here, I'm going to have this, so this will be du, and there I'm going to get negative sine theta d theta. So now it's good that I have a sign here, such that if I replace my u, this sign in the equation or in this integral is going to have to go. So I multiply both sides by negatives, such that I have negative du equal to sine theta d theta, like this. Now let me replace my u. So let me replace my u. Let me now write it in terms of u. I write the function in terms of u. Okay, so what do I get? So I have the integral, then I have 1. So where there is cos squared, I replace the u. So I have u squared, then I have squared there. Then here where there is that theta d theta, then I just have my what? I have my negative du. So negative du. So I factor the negative in front, and I have my du there come. Okay, so now what do I do next? From then, I'll replace it now. It's now a U substitution. I can expand that. So let me expand that, and I just have, okay, I'll get 1, then 1, multiply that there just gives me negative 2 u squared, then of course I have a plus u to the power 4, then du. Okay, from here now I can integrate each term with what? With respect to u. So I keep the negative out there. Then the first part I just get that to be u. Then I'll have there negative 2 u to the power 3 over 3. Then what do I get next? Then next I just have this will be plus u to the power 5 over 5. Then like that, plus my constant c. So I can now distribute the negative. So if I distribute the negative, I'll end up having a negative u plus, so negative u, that would be 2 over 3 u. So that would be plus, yeah, positive 3. Then that would be negative u to the power 5 over, yeah, to the power 5 over 5, then plus your constant c. At this stage now, you can replace back what we set to be our u, and we set our u to be equal to cos theta. So the first part, I just have negative, this would be negative cos theta, then that would be 2 over 3. That would be then cos theta raised to the power 3. Then the next part I have, that is just going to be cos theta raised to the power 5 over 5, then I have a plus c, like that. So that's how I integrate that part. Okay, let's do the second part. Now, second part, what does the second part say? So for the second part, we have that the integral of 1, must find the integral of 1 over, so I have a square root, then x squared minus 4x plus 13. So dx. So every time I see a root in the bottom there, what I must be thinking is, okay, I must be thinking trig substitution, trigonometric substitution, or a hyperbolic substitution. But before I do that, I must then, I must complete the square in there to see, do I get any of the standard forms of maybe a trig or hyperbolic substitution? So let me complete the square on there. So if I complete the square, I'm just going to have, so that will be x minus, I have that, then I get 2, then I square it, then of course, okay, so half, then, okay, so what do I get here? Okay, I mean, this, then there, I'm just going to have, so I square the 2. So if I square the 2, I'm just going to have, I'm going to have 4. So 4, then plus the 13, like this. So this is what I get, 4 plus 13. Then I have x minus 2 squared, then this here gives me positive 9. So I can replace this there into my what? Into my integrand. So what do I get when I replace? So I replace, then I have the integral of 1 over root there. Then I have x minus 2 squared plus 9. So now, because of that plus sign there here, I noticed that, okay, this here is just in the standard form of what? Of having a variable x plus the constant y, a raised to what? To a power there. And always when I have such here, I'm going to let my x to be equal to what? To tan. That way I can easily what? Use the trig substitution. So what are we saying here? So the next step is we're saying we let this, the squared part, x squared like this, be equal to what? So the standard is letting x be equal to a tan theta, like that. But now look at this case. My a is just, so if I write this, so I can write this as the integral of 1 over, so that would be x minus 2 squared, then I just have plus 3 to the power 2. So writing that here, the a is actually what? 3. So I'll get that x minus 2 squared is going to be equal to, so it's going to be equal to 3 tan theta. So 3 tan theta, of course, not the squared part. I'm not squaring it. I'm just getting what is inside there. So what we're saying is you get the x minus what? Minus 2. X minus 2 is what you put there, and you say tan 3 tan what? Tan theta. Okay, so now I can make x a subject. Then this is just going to be 3 tan theta. Then I have plus 2. Then I can differentiate now. So I have dx this side. Then what will I get on the other side? The other side I have 3. I differentiate tan theta. I just get, this will be sec squared theta. Differentiate 2 is a constant. I get 0. So, and of course the theta here. So this is going to be my what? My dx. And this is what I'm going to what? To replace in my equation there. So remember I said, we said we can replace this part, x minus 2 with what? With tan theta, and we can do that now into our what? Our integrand. So let us now replace that. So what do we get? So we get that this here is going to be the integral of 1 over So the first part, which was, okay, so we had something like x minus 2 squared, then plus 3 squared, which is just 9. So now I replace this with the 3 tan theta. So I have 3 tan theta squared, of course, plus 3 squared, which is just a 9. But I'll just get the integral. This will be the integral of this. Remember my dx, I must replace my dx as well. But my dx is just 3 sec squared d theta. So here I just get 3 sec sec squared theta d theta. So that's what I get. Then now, what do I, the other one here, I square now what's there. So that to give me 9 square, 9, the square 3 gives me 9. Then I get tan squared theta. Then after getting that there, I have a 9 there. Okay, so can do that. Okay, not only can we do that, then here we can go further on. We have sec 3 sec squared theta d theta on top. Then down there we factoring out 9 is common. Then I have tan squared theta plus 1. Okay, so what does this give me? So now remember, this tan squared theta plus 1 is just an identity. So if I say I have the sine theta plus cos squared theta is equal to 1. If I divide by cosine throughout, cosine squared theta, like this, cos squared theta, cos squared theta, what do I remain with? I remain with the first part becomes tan squared theta. Then I have a plus 1, and that there gives me what? That gives me sec squared theta. So this tan theta plus 1 can just be replaced by sec squared what? Sec squared theta. So this will just be the integral of 3. So like that, x squared d theta. Then this here, 9. Then I replace that there is sec squared what? Sec squared theta, like that. Then okay, so now from here, I will get the value. What does that give me? I can remove that out of the root. So I'm saying 3 squared 6 sec squared theta d theta. Then I have over, so 9, the square root of 9, this gives me 3. Then here the square cancels, then I just remain with what? Sec theta. But this then can divide into there, and I just remain with the integral of what? Of sec theta d theta. So that's what I remain with. Okay, what do I do next? Okay, after getting that, now this here, when I integrate, this is just going to be equal to what? This gives me ln of, so this is just ln of sec theta, like this, plus tan theta. So this just gives me sec theta plus tan theta plus what? Plus c. So this is what I get, sec theta plus tan theta plus c. Now, I have to write this. Remember, it's given in terms of what? Of x. So my final answer has to be in what? In terms of x and not theta. So how do I get that now? So remember that we had said, that x minus 3 was equal to what? Tan was equal to, this is minus 2. 3 here was equal to tan theta, like this. So x minus 2 is equal to 3 tan 1 tan theta. So making theta, tan theta the subject. So how here x minus 2 divided by 3. This 3 when I divide, then I just remain with tan theta as the was is. So the tan is just toward, opposite over what? Adjacent. So this here is the what? Opposite, and that there is the what? The adjacent. So if I was to draw my triangle, I can draw a triangle. I can draw a triangle in terms of what? A right angle triangle, like this. Then I write it in terms of this here. So the adjacent, if I have my angle theta to be here, my adjacent is going to be 3, it's going to be here. My opposite is there, and this is just going to be x minus 2. Then how do I get the other part? I square this part, square the other part, then find the square root of it to get the hypotenuse. And that will be just x minus 2 squared plus the other part squared, which just gives me 9. 3 squared gives me 9. So I get that there. Now I want to get what? My interest is to get the tan, since I already know what, I mean to get sec, because I already know what tan is. So what is sec? Sec theta, sec theta is just equal to 1 over what? Over cos theta. And what is cos? Cos is adjacent over hypotenuse, meaning sec is just hypotenuse over what? Over adjacent. So my hypotenuse is the x minus 2 squared plus 9. Then my adjacent is what? Is 3. So that is what I get to be my sec theta. So write this again. So we just get that sec theta will be the root of x squared minus 2 squared, then plus 9 over what? Over 3. That is going to be my sec theta. So now I can replace there where we said ln sec theta is just going to be root of x minus 2 squared plus 9. Then I have over what? Over 3. Plus my tan. Remember what I said my tan to be. So my tan theta was just x minus 2 over what? Over 3. So I'll have x minus 2 over 3 like this. Then of course the modulus plus what? Plus c. Further on, since they have the same base, I can keep that. Then I just say this is x minus 2 squared plus 9, then over 3 everything, then plus x minus what? Minus 2. Okay, then ln plus what? Plus c. But then this uh, I'm dividing all this expression over what? Over 3, and I have ln there. So I can write it. Let me now write it. I can, using the laws of logarithms, here I can write this as ln. I say this will be x minus 2 squared plus 9. Then I have plus x minus 2. I close there. Minus, because it's division here. Minus ln of what? Ln of 3 plus c. But ln of 3 is just a constant, meaning it can be absorbed in this constant, what? Constant c. So you just have a constant altogether. So that would be just ln. You were left with ln x minus 2 squared plus 9. Then I have a plus x minus 2 like that, then plus my constant c, because it's been absorbed in there. So this is how we integrate what? These two questions. This is how we integrate these two questions. Well, if you're new to this channel, remember to hit the subscribe button, to like for more notifications, and to get full access to the all solutions of the assignment. Remember to register with Discrete Learning Institute, and you can find the solutions online. Well, it's very easy to access these solutions online, and how we do it is as follows. So how we do it is, so let me share my how we do this. So the way we do it is, okay, let me just share my screen. So, right, so the way we do it is, okay, so the way we do it is here, we are going now to go, so you go here, uh, okay, so you go there, and then you register, you say discrete, uh, discrete learning institute.com. So it directs you to that. Then here you can select the first part there, that link. So, uh, okay, so you select that there. Then what you do is, if you do not have an account, it will bring you an option where you make an account. So let me just sign out first. So if you do not have an account, you come here, you subscribe to course, or then you can scroll down and then you find an option where to create an account. Then if you're already registered or you've already have an account, you just go and start learning, then start learning here. So as I said, if you do not have an account, you just come here, create account, then you'll be able to create account. Then if you have an account, just log in, then like that. After logging in, then you go to the course which you registered for. So now we're talking of calculus. So here is where it is. Then now you go into the folder tutorial sheets and assignments. So tutorial sheet and assignments. Then from there, you just go to written solutions like that. Then you open 2025 solutions. Then from there, you can open here on assignment 2. Then it will direct you to the assignment. So it will direct you to assignment, and here you go. This is the assignment, and okay. So this is the assignment. This is question 5. You can, from there, you can be able to access other things. So remember to subscribe like that. All right. Thank you, and see you in the next video.